Yeah, so reliability tests all the way down. And my disclaimer, I always have to have a disclaimer, honestly. But I'm not here to sway you for any product or another, nor any paradigm or another. I'm just here to give you some info that you can then choose to accept, ingest, if you will. And of course, complaint department. Yes.
Isn't continuous improvement a paradigm versus sitting around and letting things break?
Continuous improvement. I guess it is a paradigm that I'm saying to that I am suggesting. So you caught me, one loophole. That is one that I will suggest. So, yeah. Thanks for pointing that out. It's good to know that we have a lawyer in the office. Uh, but anyway, so yeah. So let's go back to when things were simple. Or were they? Some of you folks might recognize this image. This is one that I've used in my past here. Pulled it out from the backlog here, but yeah. So this is my cool app. This is the monolith, right? This is how we used to have our applications. One application, one deployable that included all the good stuff. Then there was client server and that, but we'll just leave it at that. But yeah, development was handed off and given over to QA where they went to finish it off, right? Developers, ultimately got introduced to test-driven development, started doing some of the unit testing, but still deployments were infrequent unless there were bugs, right? That's when you would do more. Scaling was, of course, vertical, and we loved our servers. They were our pets. Then we kind of started breaking things up a bit. Another familiar image, yes. Yes. Domain-driven development. We realized that the monolith is really not the way to go. We started breaking things up based on domain or similar features and that. And that was a cooler app, right? But yeah, so, and really because the monoliths became overly complex and yeah, just kind of difficult to work with. I mean, we've had some of those situations here at NISC. You know, breaking up things then made our teams a little bit more agile. They were able to work together in isolation from other teams, so they were able to, work quickly, or at least more so. Testing practices stayed pretty much the same though, right? We created the application, we handed it off to QA, they went through, did the testing. Not talking about JUnit. We would still have that in there, the unit tests, but we started getting some more of the testing products, Selenium, JMeter, Postman. APIs were becoming more and more important because now we had these separate deployables, and then they would often communicate with each other. So we started getting into our VMs and the cloud at this time. So then, here's another one you might look familiar to you. Then we started doing microservices, which was even exploding it even more, right? We were creating the Netflix of our own, and of course, the image on the right there is some activity from a Netflix service. I'm sure it's worse by now, but a lot of connectivity, a lot of things interconnecting and talking and all that. So very complicated. You can't really figure out the whole thing just from one application. And then the finer grained services were there, so you could even do now serverless functions, so that way then even smaller, finer grained applications. The more teams and services and more APIs, the code base or the overall system became more complex. You could start doing some hyperscalability based upon the metrics and the request, queue depth if you were looking at Rabbit or Kafka, that type of a thing. We started using a lot of the best practices from the 12-factor app, which just made sure that everything was independently deployable, and it encouraged resilience. And shift left became a thing. That's when we were really pushing that. The testers were overwhelmed, right? they're getting this massive services coming through them. They become a bottleneck. Developers get upset. So developers need to take on some of that work and make sure that they're pushing quality before it goes to the testers. And of course, as things evolved, we fell in love with our containers and Kubernetes ultimately. And for those of you here at NISC, I'm sorry. I was one of, I guess, I don't know, the start of the microservice paradigm here. It's one of those things where it's like, it's a good thing overall, but one of those things where it's like, now that I've come back, it's like, oh, maybe we let that pendulum swing a little bit too far, and it's really causing more problems. But anyway, I digress. So for now, the follow-up act is, the continuous process that to deal with all these. So here's our actors. We've got the developer, and then we've got the tester. And then we've got our, yet another one, right? Code reuse, essentially. But yeah, so we have our continuous loop here, our software development lifecycle as it goes through. We created this whole DevOps paradigm for dealing with all this. And of course, yeah, the site reliability engineer becomes a thing. Now, again, my disclaimer is, and as you alluded to, Lawrence, on earlier with some of the different manual tester versus, whomever, the SDET, I'm just being really simple and generic here. So SRE is anyone that's working on keeping the infrastructure and all that, to platform engineers, things like that. Developers are, creating applications, features for consumers to use. And then the testers are just anyone involved with ensuring the functionality. And then, of course, you're going to be wearing multiple hats. It just depends on what you happen to be working on at that time. So here we go. So let's start at the beginning, right, with the planning phase. So with the planning phase, we want to establish really baselines for the performance. Bless you. The SREs and developers can agree upon the stack and the features. You can't really go and say developers, get the next shiny thing. They love that. It might be the next shiny thing. And I know I'm one of those that fell into that trap as well, right? I like shiny. But it's one of those things where you have to agree upon it, because the SREs are technically the ones that are going to keep the lights on and keep it operating, right? So they need to be able to have that depth of skill and knowledge. So you can't just keep getting the next new shiny thing, because then you're not going to have that depth of knowledge. T-shape, right? You want, wide breadth of skill, but then you want to be able to have a deep, ability and knowledge in at least something. It can't be just all shallow and going wide. But yeah, but we forgot the product. We got to let the product folks in there. They're gonna have their comments there about what features that the SREs and developers are gonna plan to work on. So next we move into the code phase. Now, and this is one of those things too, is that obviously with this diagram, everything seems like it's sequential, right? One phase, then the next phase, and then the next. And it's never like that. We all know that from daily operations, right? These are going to be going on at the same time, overlapping a bit, all that good stuff. But for purposes of this talk, we'll just keep going with this. So the coding phase. Now here's where the developers are really doing their thing. They're creating the features, they're bringing in unit tests, they're using tools like test containers to be able to do integration testing, shifting left again. Making sure they include telemetry, because once this application or feature that they're working on goes past them, the people that are operating the software need to be able to have visibility. Now, the telemetry data is how they're going to be able to do that. So they need to make sure that they're including that. They can use different technologies as well that don't have to be coded in, but this is probably the better method. And then again, developers are ensuring the performant code by profiling. They need to do profiling before it goes beyond them. Now, with the code, oh yeah, sorry, code phase continued. But yeah, so the testers should be creating their automated tests, against what the developers are producing. And based on like the things like contract tests and the load tests, they can start getting that prepared. Obviously they're not going to be running the big load tests as they're developing because it's probably not ready yet, the software from the developers, but for preparation. So as we move into the build phase, we've got the SREs building out the infrastructure. This is where they're going to be doing things like, all the good fun with Terraform, right? And building out that all those resources in the cloud for, AWS or GCP and all that. But the important thing is the testing on there. They need to also make sure that their infrastructure as code works correctly, and in that there's no confusion or unknowns about when the next one gets applied, what's going to happen. Is it going to be destructive to data or things like that? This is all things that we've got going on here at NIST. We've got the testing framework in there, and then but yeah, so kudos to you guys for that. And then again, if the new tooling was agreed upon, that shiny new tool, this is the point when they should be ramping up on picking up on that knowledge. Okay, the test phase. So again, this is going to be going on at the same time as things are being produced. But yeah, testers can do hybrid testing, and then with chaos style disruption. So the hybrid testing meaning like if it's a user interface based, so web application, they can use tools like K6 with the browser extension that can actually replicate a user actually clicking on the site. And you can do things with the back end where you take down a service or you inject latency, those chaos style experiments, where then you can see how the front end is actually affected by those outages or slow downs, just to validate the user experience. And then here too, raising security issues if they can. If they have that knowledge to try to figure out if there's ways to get around some of the precautions that are in the code. Your SQL injection type attacks or potentially even denial of service, but denial of service probably at a later point. But try to find it early, and also too make sure that the observability data that's in the application that the developers coded in are actually producing things that are valid and are maybe if the developers are creating dashboards and things like that, make sure that those are good. So then we had the release phase, which the developers, testers, SREs, everybody's agreed. We're ready to go. This is past our quality, requirements. This is when end-to-end testing should have been completed. And, load testing, the real load tests, right? Just making sure that that's all done. And then if we go into the deploy phase, quality gates. So there's projects like Kepton, which can be running in Kubernetes, and it'll actually look at your Prometheus metrics as you're doing a deploy. It actually kind of controls the deployment. And then that way then it can tell if, okay, this Canary version's coming out. We're seeing a difference in the Prometheus or whatever metrics that shows like we're having a slowdown. So they shouldn't proceed. So it can do some quality gates in that manner. And then also with, of course, the Canary deployments and blue-green. So having that all ready to go and then tested. And moving into the operate phase. So here's where the SREs are living most of the time, right? This and then the next we'll talk about. But this is where in a mature environment you can do chaos experiments against your production. But yeah, you can have your testing days or play days or whatever, and then do some experimentation like that, in a controlled manner. You don't want to take down your production system completely. You just want to find its faults. So take it to the edge where it's going to tip over already from earlier testing in this life cycle, you know. Um, but don't try to break things completely. And then keep an eye out on costs. This is where we can start doing the FinOps type things. But let's see. Okay. And the monitoring phase, which of course is the SREs again, creating their alerts, maintaining the on-call schedules, watching continuous profiling, holding developers' feet to the fire if there's a second level issue that they need to look into. They're going to maintain who is the owner of certain applications, and then, who to contact if it needs to go to the next level of support. Because again, we can't expect the SREs to be the subject matter experts on every single application, every single service. It's never going to happen. But they need to know, they have to have that call tree type thing of who to call for the issues, And then this is where we can include the kernel level monitoring with tools like eBPF, Cilium, but yeah. And then we proceed back to the plan phase. So this is where then now the SREs, they need to give the feedback back to the developers so that they know what the issues are. The developers can't fix it if they don't know what the issues are. Developers shouldn't be completely, ignorant of what's going on with the production code that's running, but they're focused on features, right? So they're not going to be paying as much attention. So they need to know, they need to get that feedback. All right. And then now there's tons of tools. So yeah, I don't know. I'm not going to tell you which ones to use. I don't know, right? And every situation is going to be different. The CNCF has loads and loads and loads of different products that need to be evaluated and potentially used to solve the issue. But, that's going to take way too long to try to go over. And although I do have plenty extra time, I thought for sure this was going to be very long. But yeah, so I had to leave it there. So questions, yes.
Can you talk more about chaos engineering techniques?
Well, I can tell you from so with K6, so I used to work for Grafana, and K6 was one of their products. So yeah, so we did do some chaos experimentation. So you could actually do things like we were doing things like injecting latency. So you can play around with your network connections. You can make it where it's like, oh, okay, maybe 50% of your calls take 10 seconds additional. What happens? Or you can sit there and you can kind of test Kubernetes, and then you can kill pods. You can target pods or services and bring them down, and just see how the rest of the application works. But yeah, I mean that's pretty much most of that engineering. You can really get most of your chaos testing is down to latency and then exceptions. You can simulate exceptions bubbling up from a service as well.
I thought they did more with entire microservices being down. For example, if your architecture is choreographed versus orchestrated, you don't have a harder time, getting everything working again because your relationships between your applications are ad hoc. There's not like a master service.
Yeah.
You start it up and everything else can start up.
You
might have like a
circular, yep. Yeah.
Due to versioning and authentication, what the microservices broke out of that loop. But other applications depend on it. So not fully circular, but circular, but all that's downstream from another microservice.
Mm-hmm. Yeah, I mean, you could do that. So the chaos testing that we did with K6 was pretty much, again, like I said, the services and deployments, or pods rather, and in the latency. But yeah, you could do things where like I don't know, maybe you're rolling back a version or something from a service to see how things behave. So then that way, then if you do have API issues, but API issues should have already been caught with contract testing earlier in your phases.
I think for us, all of the chaos testing started with just trying to restart our Kubernetes workers.
Yeah.
That alone was enough chaos.
Everything trying to start up, and then one service not being there that's core, and
But that's just the maturity level of the organization.
Yeah.
And frameworks.
Yeah. And that at least is something that Kubernetes does kind of take care of, where it'll keep killing the pod, but yeah, it might cause all kinds of havoc on your system overall while that's happening. But eventually, it'll get consistent, and it's going to try anyway. Not consistent, but to what your state is, your desired state. Yeah.
I have to chaos engineering. It's kind of interesting sometimes that 1% failure can actually be not 1% failure. Like there's one guy's like, oh yeah, 99%, successful responses, 1% just quickly cascades, especially in the microservice architecture. Because 1% is not one hit at the
might be 1% for that one service, but yeah.
Not just be one app.
Yeah.
1%.
Yeah.
Cascade failed things even if it's still 99% success
Yeah.
rates. So that's kind of goes along with to make the request up. Even 1% failure on it. A lot of times it's a big enough monkey to take down.
Yeah, 1% can be it can be a 30% to the overall system.
Just restart a DNS server.
Yeah. Oh,
Yeah. DNS, it's always DNS, right? It's something that is so central and key to everything that, DNS fails, then basically everything, right? It's caching and yeah. Yeah.
So you said you weren't going to present any paradigms or tools that you were going to recommend, but if you were to recommend,
Let's get to that.
anything on that map there?
Right? Yeah, no. So the question was, to repeat the question was, is there, even though I said I wasn't going to recommend any products or paradigms, is there anything that I would really recommend that's on the CNCF landscape? And to be honest, even though as an investor, there are so many projects there that creep up and you just don't know that they're there, because you just haven't heard of them because there's just so many. It gets lost in the noise. I don't know. There's so many of them, and that's why it's like, there's no way we could really go over this. But my hope is that if there's a specific interest in a certain aspect, I can do some digging in, a little bit more research, and and then maybe get some swag from those particular projects too. Everybody likes swag, but but so no, but that's it's one of those things. I don't know which particular area are you thinking?
I mean, I was curious about like the blue green and the canary deployment stuff, monitoring the new feature and seeing if it's different than that.
Yeah. One that's really interesting to me, honestly, is Captain. But I did do a little bit of a review on that one, and so Captain was created by Dynatrace, which is really big in the observability space, right? And in fact, their engineers are really pretty much the only ones that have been really predominantly working on it. But they went through a complete rewrite. It's pretty crazy because originally I was going to do for the Kubernetes meetup, I was going to do a talk on Captain, I did it, but my original assessment was from version 1, which had a user interface and everything, and it looked really cool. I mean, it had blue, it had red and green, just like you would think from like a JUnit test or something. and you would see those on there, and it was for each deployment, and then it would connect using a metrics adapter to Prometheus, or you could use Thanos or Influx data or whatever, and then it would read from those, and then it would check the metrics that as the deployment was going through. So it would handle actually your Canary deployment, and it was watching the metrics, and then it could automatically then stop a deployment and roll back even. So which was really cool, right? But it was working, but then they decided that wasn't cloud native enough. Okay, so they're like, okay, we're redoing it, the entire project. So now it's completely different. Now they use the I think it's kept in lifecycle management. It's something, but it's a Kubernetes custom resource now, which you'll use that way. And then what's funny too is that I was talking to some of the committers on it at KubeCon, and then I was kind of like I was really surprised, because one of the things that they did was they got rid of their user interface. Now they use Grafana. So Grafana is now that dashboard view of where the deployment is. How many failures, how many rollbacks, and things like that. But the functionality is still kind of there. But it was a complete re-architecting and rewrite of the application. So in my rating scale, I think I gave it a C+, because I really love the thought behind it. I really love the concept and everything, but it was just early days. Now that was almost a year ago, so I haven't tried it out again since. But that was one that I really liked the idea on. And in fact, here at NISC, I thought about that for the edge services, for deploying out to the edge, so.
Have you compared Kepton to any of its competitors?
Like Argo?
Argo
Yeah, no, so Argo is something that I've recently wanted to start messing around with. I never had before. Of course, Argo is the big kid on the block. That's the very popular one. It's got a lot of committers, so that's probably the one that's gonna, win out in the long run. And it's not really I wouldn't say it's well, I guess with rollouts it is a competitor, but yeah. But Argo, with its under its umbrella, it's got all kinds of other projects too, which I'm very interested in, like the workflow, Argo workflows. Just as a controller to be able to see the path of, whatever updates and where it's at in this pipeline, and as things fork and converge. But yeah, I don't know. There's so many. Like I said, I would love to be able to not have to work. Sorry, Rob. But yeah, to be able to just go through this and go through all the different projects, and then kind of do a quick evaluation, But again, though, there's no way. I would never fool myself to think that I would get in-depth knowledge on all those projects, because it's an overwhelming landscape, and that's just a little small section of it. I couldn't fit it all on the slide. So, but yeah, but I don't know. Trying to think of some of the other ones now. Dapper is one that I'm pretty interested in. So that is kind of an application skeleton framework type thing with resiliency in mind. I only know that because when I was working at K6, I kind of worked with a little bit with the guy from Microsoft who was working on that project. In fact, he was writing tests for that using K6, the K6 operator. So he was doing some things, and we were having some issues where, the K6 operator, they inject some attributes into their resource pods, and then I think the K6 operator was not enjoying that and would either ignore it or or something. But there were some inconsistencies or incompatibilities, I should say. But that is another project though, which is kind of interesting because that's one where it's like that kind of gives you, if I'm remembering it correctly, kind of again like a base application to start from, to build off of, which lot of things that are like that, like with Spring Boot. Spring Boot has their the startspring.io where you kind of generate the skeleton. Well, I think that use of these libraries and that you could maybe say is equivalent to that.
So is Dapper language specific, or is it meant to be like multi-language framework starting place?
It's going to be related to your Kubernetes deployments and that. So it's going to be related to that, but it's as all things perform and it's written in Go. Sorry, I had to throw that in. It's expected. But yeah, no. But that is one definitely I suggest to check into, because again, that makes it a little bit easier on the developers to ensure that their software is going to be a bit more resilient. Which testing will prove that out as well. What was some other ones? Crossplane. Crossplane is one that's really getting popular. I don't know. So very much like a Terraform in that it's going to handle build out of infrastructure and things like that, but it's all Kubernetes based. So you would create a lot of instead of Terraform, you'd use Kubernetes resources, custom resources for the providers and things like that. So it's somewhat, I don't know, it may be a little bit more overly complex, but it is one that is actually gaining a lot of traction. But again, how do you test that? Those things. That's the tough part with the infrastructure as code, right? Is testing. I mean, there's TerraTest. I've never actually tried it. I'd be curious if anybody here has actually tried it. But yeah, that's one. I don't know, because that's tough. And then especially when you're trying to write things for multiple different cloud providers and such. Let's see. And then of course, I'm always going to push for open telemetry. Everybody should be using that. Prometheus as well. Whether you go with Mimir or any of the other Grafana stack, whatever. But yeah. Trace test. I know I did a talk on that, and then I know folks here have tried it out, and that's a project that I really see a lot of great things from. It's very cool, and that's going to be, again, a way that you can do somewhat of an end-to-end test where you can do you can trace the activity using the open telemetry data all through an entire system and then put checks at each of the points, like how long does it take for a message to get picked up from a subscriber against a rabbit queue, that type of a thing.
Well, it makes me a little nervous with the level of coupling to the back-end implementations of things.
Yeah.
I'm always like, how tightly are we going to create tests that only work with this exact setup, and then we change one microservice and 300 tests are broken?
Yeah, I mean, it's a possibility.
I like the idea, but
Yeah.
The window of what you're testing is
Yeah.
nervous.
I agree. Yeah, with the trace test, you can actually make something very specific to that scenario, and then you try to go change it while you're breaking the test immediately. And unfortunately, I've had a lot of code that's been like that too, where it's like basically your unit test is testing that your code didn't get changed. It's not It's not checking what's coming in and out as it should. It's checking the implementation details. It's like, oh yeah, did it try to do this 3 times? That doesn't matter to the test. The test should only care about, it should be like a Schrodinger's box, right? Only cares about what goes in and what comes out. Whatever happens inside that is of no concern.
I mean, some people can type really fast, so they just replace
Yep. But yeah, and then let's see what other ones. You know, and of course I will always say K6. It is a product I truly believe in. Let's see, and what are some of the other big ones? Um, I'm drawing a blank, actually.
There was a mention of eBPF.
Yes.
I think we looked at that. I'm not sure I understood what it was.
Explain it to us, Paul.
There's a little bit of magic, but yeah, I mean that way then you can get some basic metrics without having to actually have a library directly in your code. It's just like with if you're familiar with Java Agent. You know, Java Agent is kind of, it's not in your code, but it's sitting there, everything's going through it. Well, with eBPF, it's simply looking at the kernel, the Linux kernel, and then it's able to. I don't know how it determines the messages in that. I don't know if it's just like, I don't know, it's recognizing patterns, or there's like message headers or something. Is basically what it is that go through the kernel. So, but yeah, so that way then it can give you some basic metrics at least where you don't have any, but you should always still have it in your code.
And one more, I know we started collecting a lot of data.
Yeah.
I think we got traces. I think we might even have eBPF, right?
I think we turned it back on.
Yeah. Is there a second layer of tooling that can make it useful?
You mean to actually be able to use it? Yeah. It's like when you're filling. I don't know. Can't get a good analogy for that, but yeah. There's a lot of data when you're doing traces and that. Yeah, but of course Jaeger, OpenZipkin is something. Tempo. There's a lot of them that use that same type of a method. But traces you should really probably not keep around for too awful long. Maybe keep 2 weeks at the most. And then also based on that same trace data, something huge to use is the continuous profiling, which I know we've kind of had some experiments going on there with Pyroscope, which that's a huge thing too. The flame graphs, that's nothing cooler than flame graphs.
They're isomer graphs, sir.
They're moved now. Okay. That's what I said.
They're not upward. Okay.
They have to be different.
Yeah.
I want an upward graph. It needs to be a flame.
Stalagmite, stalactite, whatever. So. Oops.
I think that'll be really interesting.
But yeah, but that's continuous profiling is definitely that's one that I did mention. That's definitely something that needs to be in there in your process somewhere.
Hopefully it doesn't impact the application too much.
That's always the thing, right? Yeah, the potential to impact your application. Yeah.
Profiling shows that your monitoring is 80% of your CPU.
That's definitely not good. Yeah. Yep. Yeah. And I know one of the things that I always liked was the service mesh. I enjoyed that Linkerd a while back, but we had some issues, I think, with some of the SSL. But yeah, I don't even remember what that was. But that was years ago. So.
It was trying to capture outbound SSL.
No.
Probably could have just turned off a flag, but instead we destroyed the whole thing.
Yeah.
And it didn't like our super old version of Kubernetes because of sidebars.
Yeah. That's.
Closed system would be better for that.
Yeah.
Setup versus you got a bunch of edge devices and half your stuff's not inside your service mesh anyway.
Yeah, and that's one of the things too is that kind of on that about having out of date services or resources or whatever, old versions of Kubernetes and that. But that's like, yeah, if people are doing their thing to make sure that everything is resilient as they can, then hopefully once it gets to the SREs, they're just kind of, monitoring. They're just watching the stuff that they've already created. They can, keep this stuff up to date. Keep doing the patches and all that. But yeah,
You live in a fantasy world.
fantasy world. I know.
You like to
There's-
all the hats
I'm an
on each other.
optimist. It can happen. Yeah. But yeah, that's, I don't know. I think-
Talk about some of the data points. What are the metrics you use to like justify up the chain for further investment in trying new stuff or
what are some of the data points for justifying the investment in some of these products? Well, I mean, so some of the obvious things are like if you're using, making sure that your, say, infrastructure as code, using things like a cloud custodian or some other type of a monitoring thing that can find out of date or unused resources to get rid of those. That's going to be a direct monetary payback, right? It's hard to tell. It's hard to say what's going to be the big cost when it's just like, well, we're not getting as many problem tickets or whatever. I mean, that's always going to be probably your main metric there, is that you're just not having the calls, and then your what is it, your SLAs aren't being violated in that, the things that you check with there, all the error budgets and all that good stuff. So, yeah.
For us, it's always been like try small experiments, find applications where you think it'll make the most impact, get some examples, and then try to sell it to management.
It also helps if like you have multiple postmortems that are like, if we just have this thing, like you're not gonna be paying a developer, God knows how many hours over how many days
Yeah.
to fix this, or you could just pay for the tool. That's another, say, not easy but straightforward data point. Like paying for the tool, you're paying for the developer to do, which one's cheaper?
Yeah.
The
Yeah.
answer is probably the tool. A lot of times.
Yep. Yeah. Yep. Developer cost versus tool cost.
Does anybody know any good tools for monitoring or creating SLOs and monitoring them with Prometheus?
Oh, I'm sure. I'm sure. It's just finding it in that.
Like alerts set up on the Prometheus metrics. And
Yeah.
it's crappy. You don't get good red, green, picturesque. Everything's happy.
Yep. Kind of a scorecard.
Yeah.
Yes. Cool. Well, I'm gonna go ahead. Like that, yeah. To be continued. Yeah, I don't know. But okay. Thank you. All right.